I'm one of the advisors for the Designing for AT clubs. So like I said, it's great to be with you here today, and first of a sort of series of speakers that you'll be hearing from this year. And I'm gonna set the bar nice and low, so because all the speakers that you'll hear from here are going to be really, really interesting people. I know most of them, and they're great folks. Today, though, I wanted to focus down on three things: learning, resources, and adaptability. And if you saw the abstract for the talk, I wanted to give you a sense of what all this means for you when you're designing assistive technology, but also kind of wrap that up in a story of how the heck it came to be that we have this entire sort of really awesome set of clubs spanning across the United States of students doing really interesting stuff for people in their community to help people do things that they want to be able to do in their daily lives, right? So I want to start with a story. And this story goes something like this. About 5 years ago, this is what I was doing. I was sitting in this chair and I had this thing strapped to my arm. This little contraption that's strapped to my arm was attached to a laptop, which was trying to figure something out about me. So I'm going to ask you all for a favor. So I'm just going to ask you to take your hand and just open your hand and close your hand. And then I want you to do something even simpler. I'm going to ask you to just take your hand, open your hand, and then just wiggle your thumb. Open and close your thumb. How many muscles do you think are involved in sort of this motion right over here? Can type in the chat, can speak up, whichever. Is it 2? Is it 10? Is it 30? Thoughts? Oh, hold on, I should open up the chat. Okay, so lots of guesses, at least one. 47, 7. Okay, so it's okay. Order of magnitude. Well, so this motion, right? This motion doesn't actually take necessarily a huge number of muscles, but there are about more or less 9 muscles involved in the control of one's thumb. And you'll notice that I have sort of this little thing over here that's taking measurements off my skin, looking at the muscles in my arm, and the muscles that control the thumb that go up to the arm, they're actually buried deep in the arm, underneath other muscles that do other things to the arm and the hand. And what was I doing with this? Well, actually, I was doing this. I was taking up a book, and I was moving it around. And then I was picking up the book again, and I was putting it back down. And then I was picking up the book again and putting it back on the shelf. And I was doing this over and over and over and over again. So this is all the while the exoskeleton is sort of trying to figure something out about me using these signals that it was getting off the surface of my arm. So after observing me for a while, the exoskeleton actually learned to anticipate me. So instead of me pushing up against it, it would move with me at the same time. I learned to do that as it was watching me, basically. So let me ask you a couple questions, and let me have you take a couple guesses. How much do you think this system cost to build? Actually, maybe a better question is, how much do you think it would cost to build today? So I have $5 grand, $400, $7,500, $760. Anybody else? 1,500. Okay, so I did a quick little search earlier today, right before this, and I would guess. So it's hard for me to say for this system because I took a bunch of different technologies that range from things that were from the 90s that we happen to have in the lab to things that I made. I would guess that this system today would probably cost on the order of $200 to $300 to build. That's it. Now, the other question that I want to ask is, how long do you think we had to use this system before it started figuring out those things about us? before it started to anticipate us properly. You think it's like, I don't know, 5 seconds, 5 minutes, 5 hours, couple of weeks, 30 seconds, 7 minutes, 10 hours, hour or two, maybe a month. Okay, so the thing is, I built this system, and it was doing something, it was doing something actually very simple. Takes about a minute. Takes about a minute and like a bunch of different grasps. But, and this is one of the tricky parts this is one of the interesting parts that I was alluding to in my abstract. The robot ended up training me. So it was, me and, this research assistant who I had with me. And we were using this over and over and over again. Now, let me ask you for a second, if you think about, when you think about how you move your hands, right? You're pulling on a bunch of different muscles, and there's a bunch of different electrical activity that happens within these muscles to drive their motion. We don't think about sort of what goes on there, right? It's just sort of like it just happens, right? And it's sort of as consistent as it's going to be. But over the course of training the system, over the course of a couple weeks, a month or two, and every time the system would be wiped, right? It's not like it was gathering information. It was like you'd use it once, it would wipe, you'd use it again, it'd be wiped. We ended up being able to train the system in one grasp. It's like about 5 seconds. We would close our hand, open our hand, and then we'd say, okay, stop learning, now just do the thing. And it would be able to follow us along. And so that is not actually it getting any better. That was us being trained by the system in a way so that we were being super consistent, right? So this is to answer the question of, what is it like to be trained by a robot? So this is sort of one of the interesting stories I like to start off by thinking about. But I will point out that, like, working with exoskeletons, working with sort of these machine learning systems, being trained by a robot was not something I ever expected to be doing in my career. And so let me give you a sense of sort of where I came from and sort of how it is that we ended up sort of here in this Zoom room, right? So originally, I can operate this properly. I started out as an aerospace engineer. So let's see, this is me over here. This is me over here. Yeah, back in undergrad, I had this weird notion that I wanted to do aerospace engineering. Learned a bunch of aerospace engineering, did some satellite engineering, and some of our satellites went up into space. And I had this notion that, hey, I really want to do space stuff. And so I said to myself, okay, I'm done with my undergrad in aerospace engineering. I want to go learn to be an astronomer so that I can then go back and, go back into aerospace. And when I build my satellites and build my space probes and go explore the universe, I will be able to properly talk to the scientists who are using these things so that we can work together really, really well, right? So I learned to be an astronomer. I actually did my master's in astronomy, and actually at that point it was kind of interesting. It was kind of the path seemed very set. I had, in my hand an acceptance to a master's degree in astronomy and a PhD program in aerospace engineering. It was going to be great. I was going to learn a bunch of astronomy, and then I was going to go build satellites. And things went hunky-dory, right? The person who came from the big cities who had never seen more than 2 stars in the sky was going to go explore space. And then things went kind of wrong. I sort of halfway finished my aerospace engineering, halfway finished my astronomy degree. And then the person who was going to be my advisor, my mentor for my PhD, he went off to be important at NASA. And so I was like, start this part of school without a teacher, or change what it is that I was going to learn. Right. And that was tricky, right? So I did kind of what one does, and I kind of like wandered around looking for a mentor, looking for a teacher. It was like, okay, someone help, help, what's going on, right? So I would talk to I went this is in the middle of my master's program. I went around and I talked to people. I was like, hey, Professor so-and-so, what are you doing? I think to myself, is this interesting? And I was like, what kinds of skills do you need to do this thing? And it's like, okay, well, like, do I have those skills? If I don't have those skills, can I learn those skills? Like, oh, no, they'll probably like turn me down because I don't have those skills, right? And I ended up talking to this professor, sort of this newish professor named Leah Sterling. And she is a person who did a lot of something called human factors. It's like, how do humans work with tools? How do humans work in their environments? How do humans work with machines? And she had done a fair amount of stuff with spacesuits, actually. But she had this little project going on related to human exoskeletons. And she said, well, we want to do something to make it a lot easier for people to control human exoskeletons. And this whole idea stemmed from my time, meaning her time, in Boston Children's Hospital, where she had worked with, people with cerebral palsy, trying to help them do rehab. And in my head, I was like, this is very different from space probes. This has nothing to do with the things that I had just learned. But, and I said to her this, I was like, oh, but I'm really interested in this. I have a personal reason to really care about, this kind of thing. And that was actually this. So this is a picture from, I want to say around 2010 or so. So this was me and my family. That's me, my mom, my dad, my sister. My sister's name is Hannah. And you'll notice that she's in a wheelchair. So my sister Hannah, great person, very nice person. Get a chance to meet her. She has cerebral palsy. And I grew up being the one to teach her how to crawl, to put a remote control in front of her and try to get her to press buttons, getting a touch screen in front of her to try to get her to touch things and control her computer and whatnot. I had a thought at that point talking to Professor Sterling. Is like, I remembered something, which was that when I was about 4 years old, before my family moved to America, I had it with the idealism of a 4-year-old, said to my parents, hey, when I'm older, I'm gonna go take care of Hannah. In fact, I am gonna go become a doctor so that I can get Hannah walking again. I think I was thinking about medical doctor. I am probably not going to be a medical doctor anytime soon. But this is kind of an interesting case where maybe I get to work on a little piece of a little bit of technology that is somehow just a little bit related to the kinds of things that would be helpful for people like my sister. Right. So at that point, I said, okay, look, I'm really interested in this. Professor Sterling, I would like to work on it. What skills do I need? And she says, well, maybe you need to know a bit about human factors. You need to know about machine learning. You need to know some statistics. And I was like, let me think about that. I have probably taken about 2 weeks worth of statistics. I don't know human factors and I don't know machine learning. And at that point, I kind of expected her to be like, oh, okay, well, maybe let's think of something else. But instead she said, no. Well, okay, no, that's fine. You want to do this. And that's what you're here for, right? You are a student and let's go learn these things. So I stepped into this program trying to work on this stuff. I didn't know any of these skills, or I didn't know a lot of these skills. And I had just finished studying Pluto. Right. Pluto, by the way, is very different from a human. Just putting that out there. So let's go back to this. Let's think about what else didn't I know? I did not know 3D printing. I did not know computer-aided design. I didn't really know electronics. I kind of learned maybe a little bit. So I went off and I hired a freshman. I said to her, Charlotte, okay, look, you gotta help me build this thing. Can you, by the way, I know that you know CAD and you know 3D printing. Can you teach me this? And she did. And I learned a bunch of stuff from YouTube, and I learned a bunch of stuff from various pieces of CAD software. And we built up, a good portion of this, right? Electronics, I learned it from the sort of night class I took, and with playing around with an Arduino. This was, by the way, back when a 3D printer cost around $4,000, or like a reasonable 3D printer cost around $4,000. I can tell you today that I can probably print off all the 3D printed pieces of this arm on the 3D printer that I have sitting on this desk that is 1 foot away from this computer. And that 3D printer costs about $250. So this brings us back to kind of the thing that I was talking about earlier, right? Point number one, learning. Learning things without a formal class, and that it's possible. And asking for help along the way helps a lot, right? This is actually a lesson that I did not really internalize until like most of the way through college, because I saw all of my friends around me who were doing like all these awesome things. It's like, oh man, I wish I could do that. And then I was like, well, I wish I had the class that they had. And like, we didn't have a class, which went and did it. Some of them, sometimes they did, and oftentimes they didn't. You can actually just, I don't think it became clear to me until a bit too late that you can actually go out and learn things without there being a teacher who is teaching a class that you are sitting in, that you are learning from, right? That's not the only way to learn things. That also brings us back to the second point, right? That there are many things available to you to help you build useful technology, right? We're all here talking about this design of assistive technology business, and I just told you how much this thing probably costs today. And the skills, roughly the skills required to do it. You can probably do it, right? And third, brings us back to our third point about humans being really adaptable, right? We talked about it in the sense of like this bit of sort of peripheral neuroplasticity, right? This idea of like, oh, training our bodies to biomechanically do things. But it's also true that we also as humans learn to do things, right? And adapt to our situations. So at this point, let's actually switch gears for a second and let's talk about assistive technology, right? So when we talk about assistive technology, we're usually talking about assistive, adaptive, or like rehabilitation devices that are for people with sort of traditional disabilities or for the elderly, right? I think that's a fair definition. But if we wanted to go a bit broader, maybe we can think about like devices that help people accomplish things that they do or want to do on a day-to-day basis, but that like sort of normal products out there might not enable them to do. So I would, for example, probably not consider this device a piece of assistive technology. There wasn't really an everyday task that this device is designed to help with, right? Like this only really works, right, in this context for someone who already is able to do this, right? But it's a research technology, right? It's something that you can use to eventually move into the realm of assistive technology. So this is basic research. This is not helping someone out, but let's talk about, what about helping people out, right? So I actually was able to do a bit of assistive tech. So this is a picture from the Assistive Tech Hackathon, and now we're getting a little bit closer to today. This is a picture of a hackathon that we held at MIT. This is something I helped out with in grad school, where we actually had a bunch of people. We had about a bit under 100 students from various places in the Boston area come in. Engineers, physical therapists, people who did mechanical stuff, electronics, software, occupational health, things like that. And we grouped them with people that we found in the Boston area who had, one, sort of a disability, two, some idea of something that they wanted to help them with an activity of daily living, right? And it was really neat. Like they came together, they thought about these products, they did a bit of brainstorming, they ordered a bunch of parts. We as the organizers spent a lot of nights organizing these parts as they came in from Amazon. And then we had like a day or so where it was just hackathon time, and people came in and they start building these things, they work with the people sort of day of. and they test them and they modify them and they realize that some of the stuff didn't work. They like run over to Target or to Home Depot or to wherever, buy a replacement thing and then replace their thing and then make it even better. And it was a pretty great success. I think I'd like to think that we made a decent impact on some of these people's lives. And I think more importantly, though, like in our context here, there were a lot of students like you who at that point became exposed to the idea that, hey, I can use sort of engineering and design knowledge to help other people in things that I don't even think about as being like difficult, right? So then I started my job at Lincoln Laboratory, and about a month and a half later, this guy, this at that point a division head named Bob, approached me about something called the Beaverworks Summer Institute, and he actually roped me into making a new assistive technology class. And so it became something like this. We had a bunch of people in 2019, we had a bunch of people this past summer doing a bunch of awesome projects. And by the way, this is basically the class that y'all are seeing sort of replication of, right? And this is the class from this past summer that has spawned the set of clubs that many of you are involved in now. And I apologize, I have more than 3 words, I guess. But I'll give you a guess of what it is that we talked about. So one, we would talk about things like, hey, the assistive technology potential product space is so large that we don't know the answer. I'm not sort of a traditional teacher where I can tell you that 2 + 5 is this for sure, right? It's sort of like, oh, how do you build this thing? Well, you could do it this way or this way or this way. I don't quite know how to do it the third way, but you might be able to talk to so and so. We talked about learning things without a formal class and about how to ask for help along the way, right? And I want to sort of press on that point a little bit. There are some things that you'll notice that are easier to do that for. That sort of adage applies to a little bit more, right? Easily. Some things where the startup requirements are pretty low, things like programming or computer-aided design, where you plus some person on YouTube will figure it out. There are some things that are harder and maybe require some amount of resources. So for example, if you wanted to get into like an assistive technology design for like a garment design, or you wanted to do something like, electronics, additive manufacturing, woodworking, like those things are definitely accessible from home, well, probably, but they take a bit more resources, right? And then there are some things that are even harder, right? And you might need to pull in extra people, you might need to be near some location, things like if you wanted to learn how to use machine tools, or if you wanted to learn how to do physical therapy, you wanted to learn how to do rehab, like those things are harder, right? But one way to think about it is like when you're thinking about this class of problems of assistive technology problems, what is the problem that you're actually trying to solve? And maybe how much of it can you get done with the resources that are available to you? Right. I had the sensors from the 90s. I had the $4,000 3D printer. I had the freshman who was going to help teach me how to do CAD and 3D printing. How do I extract a PhD from that? Right. For you, it's like, well, I have a school. I might have a workshop with some level of resources. I might not. I don't know. Maybe I'm near a university, maybe I'm not, maybe I'm near a makerspace, maybe I'm not, maybe I have a neighbor who's just really handy, who I can ask. What resources do you have access to, and how much of the problem can you solve with what you have, right? And one of the points I want to point out there is like, other people are pretty smart too, right? So asking the right person, the right question, can probably save you weeks, days, months, sometimes, of work, right? Especially if they just kind of point you to the right direction. So it's not like these kinds of projects, I want to emphasize to people, this is not like a class project. This is not the idea where, oh, you have to struggle through it on your own. I mean, sometimes it's good to do that, but sometimes you ask, how do I do this? And that is what gets you the learning, right? We also talked about the resources that are available to you, right? So things like, electronics how-tos, custom order manufacturing, people who have done this kind of thing before are the things that we talk about in this class, right? We tell people, hey, did you know that if you don't happen to have a 3D printer at home, you can get someone on the internet to print something for you? Did you know that there are people who have done X, Y, Z before in the past who will be able to help you, figure out how to design this garment, right? Asking the right questions and using the resources that are in front of you. And we also talk about adaptations. Right? In this class, and hopefully in the clubs that you're working with, we're always encouraging people to talk to the folks that they're designing for, they're making the products for. Right? These are the people who are living the experience, and there's a decent chance that they have their own adaptations to doing the thing. That maybe what you have in mind, it might not be, and you got to figure it out, right? How does that affect how they interact with the thing that you're making for them? Right? Is your preconceived notion of the way that they're going to use it actually the way that they're going to use it? Yeah, you got to see, right? And also, like, on the flip side, if humans are really adaptable, you are also really adaptable, right? In doing these kinds of projects, you're probably going to be using a lot of skills that your school doesn't directly teach you. You have to adapt. Right. So, I'm gonna draw to the end here. Designing for assistive technology will probably force you to learn things that you are not taught in a regular classroom. That doesn't mean you can't learn it. Resources, right? There are resources out there. They're getting increasingly easy to access. They are probably cheaper than you think. But importantly, you all right now here in this Zoom room are each other's resources, right? Should take this as an opportunity to go meet someone and figure out in what way they are smarter than you. I guarantee you that every single one of you is much smarter than me in something, probably many somethings. And usually what you do is, if you're clever about it, you then go figure out, what exactly it is that they're smarter than you in, and you learn nothing from them, right? And adaptability, right? Learn about other people's adaptations as you build products for them, but also be adaptable as you do these products, as you do these projects, as you work with each other in your teams, right? So learning, resources, adaptability, that is what I have for you today. Thanks for having me, and I'll be happy to take any questions.
Thanks, Hosea, for the great talk. If you have any questions, feel free to raise your hand using the Zoom raise hand feature, or feel free to type it in the chat. Yeah, so I guess we can start off with our first question. So disabilities are often negatively stigmatized. How would you suggest for one to better empathize and build relationships with people living with disabilities?
I mean, it helps if you know people, right? So one of the things that we often find is that people who are drawn sort of to the space are drawn to the space because they know people who live with and experience some kind of disability, right? If you are a very fortunate individual that you don't know anyone like this, think of perhaps your elderly grandparents, right? They were once as young as you are, and things are not quite as easy as they once were, right? One important thing to remember is that there is really a spectrum of ability, right? It's not like, oh, this person is disabled. I am not, or I am, or I whatever. There are some things that are difficult for you, and there are some things that are difficult for other people, and it kind of comes in different forms and flavors, right? Again, remembering the adaptability side of things, When you see someone who you think of as having maybe a traditional disability, like, yeah, sure, you might see that they have that disability, but one thing to keep in mind is they probably have some adaptation for that as well. They're humans are adaptable folks. Maybe try to figure out before you immediately go try to help them. Well, do they even need your help? Or maybe they're fine. And they're people. They ask, sure. Not like that's maybe just important thing to keep in mind, right?
I'll have a question next.
Yep.
So question was, where can we expect to see your research applied to like day-to-day life?
Yeah, so applications of research in day-to-day life, it's going to take a while. I tend to think about my research in two areas, right? So one, sort of broadly speaking, the kinds of research that I do are, well, if you're going to call it research, that means it's probably not going to show up for a while. Otherwise, it's probably not very much research, right? The kinds of research that I do focus on, like how humans and machines work together, and how to sort of facilitate those relationships so that we can work together as teams, right? So that stuff might show up in, perhaps advances in exoskeleton technologies. It might show up in advances in human AI relationships, how we work with computer systems that are also sort of cognitive and thinking, right? Because a lot of the times when people are building computer systems, they think, oh, how do I make this the most adaptable thing in the world so that it works with everyone? And again, they forget the notion that, yeah, you can make your robot or your AI or your Siri or whatever as adaptive as you can, but humans also learn and humans also change. And that's also one thing that I'm kind of trying to push on the research side. The things that are actually maybe hopefully going to make it out into the real world are probably closer to these AT projects, right? That I'm helping out with. So there's the stuff that maybe y'all are going to do that maybe I'll have a very, very small part in. And then there are a few things that I'm going to try to be building at various times. Things like trying to make my garden gate at home in New York openable by my sister. By the way, there's an AT project for you if any of you are in New York. That's the kind of stuff that's going to make it out into the real world much faster.
Yeah, I think our next question is, in the future, like, is there anything that you hope to work on in assistive tech, like besides exoskeletons, or anything in particular that you'd like to do for the future?
I'd like to get that garden gate working. Yeah, so like there are things like that. There's also like, I'm also quite interested in, I'm getting more and more interested in this idea of sort of the human side learning of like, what are the things that are still possible for an adult to do in terms of rehab. Because ultimately, like, I think assistive tech is great, but you won't always have it with you, right? So I want to sort of get a better sense of what are the things that actually need assistive tech, and what are the things where really the solution is to do some sort of therapy, to do some sort of rehab work, right? So maybe that's less of a technology. You can involve technologies, but that's kind of where I'm thinking right now. And again, that's also something that I don't really know, right? Like I do not have a formal education in like physiology or physical therapy or rehab. I'm thinking about it.
Yeah, I guess that sounds dope.
Yeah, Parker.
How do you think like your exoskeleton like research and like Yeah, do you think that would like accelerate the rate at which we make like androids or like AI, like, like the Iron Man idea, like if you put those pieces all together, like more complex movements, like miniature.
Yeah, let me show you something. So I figured this question would come up, and yeah, so here we go. Why can't I? So here are the other pieces that I'm working on, right? Working on upper body exoskeleton. Just spent 3 years working on a lower body exoskeleton. As you can see, they'll gradually come together until you have a full suit, right? So this is a machine learning controlled lower body exoskeleton that we worked on. There's some work that I did with human control of aerial vehicles and how humans and AI can work together to control these things. And then actually I have this little thing here for a card game called Hanabi, if anybody's ever played that. This is how like humans and AI teammates can work together. So to your question, so these are the things that I'm kind of working on professionally. That's why I think I'm actually not too far off by saying, I'm working on the various pieces: physical, cognitive, machine learning, AI, that eventually, if you bring it all together and you give it a nice coat of red and gold paint, might look familiar. But I think these things will probably take a different form than most people think about. Right. So like exoskeletons, I think what we're seeing is like, giant full body exoskeletons are probably not the way to go. Right. Augmenting specific joints to help with specific motions, to reduce the energy cost of running or walking, to maybe make it so that when you lift something, your shoulder doesn't get torn, right? More targeted sort of innovations might be needed, right? And that's one of the ways that where I think like, these things can kind of come together, but be a little bit different from what people think. There's also the idea that like, the mechanical engineering here is like pretty good nowadays. I think the mechanical engineering is like pretty close to being there, to being able to be a help rather than be a hindrance. But this idea of humans being able to work well with these systems is not something that I think a lot of the mechanical engineering folks who used to do this were thinking about, because they were still trying to get the stuff to physically work, right? But now we're at that point where you do need to think about, how are people using these things? How are you communicating with the robot that lives on your body, right? So it's probably going to look a little bit different. Raymond, and then I think I have 2 questions on the chat.
Yeah. Hi. So this might be a little weird question to ask, but do you think that the Iron Man suit is technically considered an assistive tech for Tony Stark, because it's also augmenting his his ability to be a quote superhero, and also keeping a shrapnel out of his heart? Because
well, I mean yeah. So that's the chest thing, right? So yeah, sure. The chest thing is keeping him alive. I'm not sure that's so much of assistive technology as it is like a life-saving device. I don't know. I think, okay, so technically, if you go by like what our previous definition of assistive so it's an augmentative exoskeleton, not so much an assistive, because Tony Stark can do normal day-to-day things without the Iron Man suit, right? So I think no. I by the way, these are the questions that I do actually think about professionally. I have a paper where like we list out a whole bunch of things, whether or not we consider them exoskeletons. I think Megazords and Jaegers from like Power Rangers and what's the other one from Pacific Rim are not exoskeletons. Let's see. Okay, so I had a question from Lynn. Yes. Linnea. Is that how you say your name?
Oh, Linnea.
Linnea. Do you want to ask a question?
Out loud?
Sure.
Okay. I was wondering, like, in your opinion, what the most helpful thing to keep in mind in order to get the most useful interview results is.
Listen.
Okay.
Yeah. All right. Listen. Have a rough plan. A lot of people, I think, sometimes people go a little bit too far and like they have a list of all of the questions that they want to ask, and they don't let their interviewee sort of lead them anywhere, even if their interviewee is like heavily hinting that they want to talk about something else. So don't have like this massive list of questions. But on the other hand, like, you know, if there's like long dead silences, right? You want to have something of a plan, but you want to listen, right? Figure out where it is that this person is taking you in the conversation. What information are they giving you? Vivek, do you think you'll ever use your background in aerospace engineering and assistive technology? So my background in aerospace engineering is actually probably closer to what is considered sort of human and autonomous systems. So actually a lot of what's called human factors, there's a significant portion of that that came from aerospace engineering. And yeah, I use that all the time. I use that in everything from, so, you know, they had things for how do you get a test pilot to tell you about the handling qualities of the aircraft, right? We use kind of similar techniques to ask people how they interact with machines, how they interact with assistive technologies maybe. It depends on kind of the context in which you're doing this. And then autonomy, certainly, I think it depends. I don't tend to deal necessarily with assistive technology that's necessarily very high on the level of sort of autonomy, right? I'm not building self-driving wheelchairs. I guess you could. There is a lab here in Boston that does that. I don't do that, but like you could. And some of those ideas kind of go there as well.
So another question that we had was, what advice would you give high school students when considering what college or major to apply to if they're interested in assistive technology?
Yeah. This is tricky, right? There don't really tend to be like, oh, major in assistive technology at like such and such university, right? I'm not even quite like, I guess I could maybe kind of put together a curriculum that would cover that, but like assistive technology is really, really broad, right? As you can probably see. So there are going to be sort of a number of more traditional sort of supporting disciplines that one can take that are more common, I guess, right, in universities. And you can, I think it becomes up to you how you want to approach the problem of assistive technology, right? So one common approach is to take a sort of mechanical engineering or product design pathway, right? You learn to build consumer products. And maybe you learn to build something and interview with people, and you learn the specific manufacturing processes to build something for 1,000 people. You can scale that up, you can scale that down, you can scale that to particular needs. There's sort of the more design approach of things that tends to be maybe de-emphasize the engineering, emphasize the sort of design process. There's the approach that's maybe a little bit closer to medicine, where, for example, if you're doing like, you know, majoring in kinesiology, or you're majoring in physical therapy, or you're majoring in like occupational therapy, something like that, right? Then you're taking a bit more of a, you know, how do I approach AT kind of problems from a more medical perspective? Of course, you can also do things like, you know, CS, electrical engineering, you know, as you kind of saw, right? There are a lot of things that go into assistive tech, right? One of my good friends, she started off with, what is it? I think it's fabric. No, it's not fabric design. It's like textile engineering, textile something or other. She made clothes, and now she does rehab. And a lot of stuff is actually like it's a similar skill set. You're making stuff that fits on people, right? And then there's some people who do software, they do assistive tech, right? So I think you have a pretty broad range of approaches, and maybe assistive tech is more of an end goal than a specific pathway.
And a follow-up question to that is, a lot of us are seniors right now, and so when we get to college, do you know of any opportunities or programs or organizations that high school students or college students could participate in?
Well, let's see. So if you are, maybe there's a handful of you here who are not seniors yet, you should go apply to the BeaverWorks Summer Institute. Nice little plug there. I think I'm like contractually obligated to plug that or something. But you know, it's there's like a whole bunch of different classes that you can take. A lot of classes that I wish I could take at the time to take in a lot of different things, ranging from, you know, building AI systems to doing, you know, electronics and 3D printing to doing things like assistive tech, right? But I think things sort of in the university sphere, I think a lot of programs that are, a lot of schools that are affiliated with hospitals tend to have programs working with them that might make it easier to do this kind of work either in class or something like that. I'm not sure that there is sort of like, I don't think I can point to, here, look at the national chapter of, or the state chapter of XYZ for that is like very common across universities. Unfortunately, I'm not sure that that quite exists because AT is maybe not quite as organized at that level. But again, something for you to think about, something for you to reach out to. Maybe a specific piece of advice that I will mention here is you can look at the faculty for, you know, whatever university that you're applying to. Are there people there who are doing things like this? And it might not necessarily fall under the keyword assistive technology, right? To think about the many, many, many words that people use to refer to these things. You know, is it accessibility? Is it user-centered design? Is it human-centered XYZ, right? And then you go reach out to them, just send them an email. It's a little easier once like you're a student at the place, but you can do it whenever they might respond.
Awesome. So I think that's it. Is there any last message you'd like to leave our audience here today?
Was that a dab? Well, okay, let's see. What message would I like to leave? Well, first of all, thanks for having me. Second of all, I think what you all are doing here is really, really great. And it's really, really important, right? I'm not necessarily here to convince you to be like, yeah, and therefore go do assistive tech. Well, yes, go do assistive tech, but also like, you know, if you don't end up doing it, or if you do, like the idea that you can in fact use your skills to help the people around you is a really, really, really important thing to keep in mind, right? And that's something you can keep in mind when, you know, you are doing frustrating pre-calc homework, when, you know, physics mechanics is beating you over the head with, you know, beams and trusses and whatever, right? Those things can come in handy and can be used to help the people around you, right? So something to keep in mind.
Yeah, I think that's all. Thank you so much for this talk. And physics is definitely beating me in the head right now. But before the rest of you guys sign off, yeah, Dave will be talking next month on November 12th about engineer design process in assistive technology, and he's a Stanford professor, so he has a little bit of experience with assistive technology in college. And yeah, thank you all for joining.
Thank you guys.
Thank you. Bye.
Bye.
you.